All right, here's 10.2 Systems of Linear Equations by Matrices. All right, so what we're going to do is we're going to start using matrices to represent a system of linear equations, and specifically an augmented matrix. To write an augmented matrix, what we're going to do is we're just going to say, you know what, writing the x's and y's and z's are getting in the way. So a matrix, what we can do is we can just write rows and columns. So our first row is going to our first column will represent x, our second column will represent y, our third column will represent z, and we'll augment it and have it represent our constant. We'll just use k as our constant. So for this first equation in the matrix, it's going to be 5, -1, -1, 0. Then the x is 1, the y is 1, there's no z, so I put a 0 in it for there, and it's equal to 5. I have 2 x's, some 0 y's in that equation, minus 3 z's there, and you're going to get 2. That augmented matrix is representing that system of equations. For 2, if I'm giving an augmented matrix, I can go ahead and write the system of equations. I can get that 6x minus 2y is equal to 1, and that 10y is equal to 5. So I can go both ways looking at my augmented matrix and put it into a system of equations and vice versa. So what we're going to do is we're going to do very similar to elimination, but we're going to do it with matrices so that it alleviates a lot of our notation. So perform row operations on a matrix. So the 3 things that we can do is we can interchange any 2 rows. We can replace a row by a non-zero multiple of that row, so we can multiply any row by a number. And 3, we can replace a row by the sum of that row and a constant non-zero multiple of some other row. So I can add and subtract rows and replace them with another row. Okay, so that is our row operations. So what we're trying to do, our goal is to get into the reduced row echelon form. If we eliminate things and we get our augmented matrix into this, you can see if I put it into a system, I get, this is my solution. X is equal to A, my Y is equal to B, and my Z is equal to C, because for all these other ones, we're zeros there. So a reduced row echelon form, I'm always looking for ones in the diagonals, okay, and everything under the 1 being 0. That is just row echelon form, but we're always going to try and do in this class to do a reduced row echelon form, which means that this top is also zeros as well. So let's go ahead and look at an example for a reduced row echelon form. So first thing I'm going to have is I'm going to have my matrix here, or my system of equations, and I want to write my augmented matrix. So my augmented matrix here is going to be 1, -1, 1, 2, 0, -2, 1, 2, -2, -3, no z, so that's a 0, and then 1/2. Okay? So as I'm trying to think of getting this into reduced row echelon form, I should understand that my goal here again is 1, 0, 1, 0, 0, 1, and then replace these with zeros, augmented with some number A, B, and C, and those will be my solutions there. So first thing I want to do is I want to recognize this top row is really nice because I have a 1 already there. The next row is nice because I have a 0 here, so I eventually just want to get that to a 1. And I'm going to try and do some eliminations here so that I can get the third one to fit in here. So first thing I'm going to try and do is I want to deal with trying to get this -2 to be a 0. So just like elimination, I'm trying to eliminate my x's while I'm trying to deal with my first column here. Well, to deal with my first column, what I want to do is I want to do 2 times my row 1 plus my row 3, and that's going to put into my new row 3. So I'm going to use capital letters to represent new rows and lowercase letters to represent the old row from the previous step. So if I go ahead and do this, I'm going to see that my matrix will go to this. So my row 3 is the only one that's changing. So the 1, negative 1, 1, 2 is going to be the same. 0, negative 2, 1, 2 is going to be the same. But my row 3 is what's changing. So I'm doing 2 times my first row plus my third row. So I'm going to get 0, negative 2 plus negative 3. I'm going to get negative 5. And I get 2 plus 0 is just going to be 2. And I have 2 times 2 is 4. 4 plus 1/2 is going to be 9 halves. So there's my augmented matrix. So similar to my elimination, now that I've noticed that I got zeros in that first column on the bottom 2, I want to try and go ahead and eliminate this negative 5 there so that I can just get z by, or the third column by itself, and get a 1 there. So what I'm going to do is I'm going to recognize, well, negative 2 and negative 5, I can't multiply one to get the other, so I'm going to have to multiply one by the other. So in other words, I'm going to have to do 5 times row 2. That'll give me negative 10, and I want to eliminate negative 5, so I need that to be a plus 10. So I'm going to add that to negative 2 times my row 3. And that's going to be equal to my new row 3. So as I do that, notice rows 1 and 2 will be the same. So I'm going to have 1, negative 1, 1, 2, 0, negative 2, 1, 2. Then I'm going to have 0, 0 here. And I do 5 times 2, I'm going to get 5 minus 4, and I'm going to get 1 there. And 5 times 10 times negative 2, which after I do 2 times that, it's going to be negative 9. So 10 plus a negative 9 is going to be 1. So now I have my third row simplified to be in reduced row echelon form. Let me clean this up. All right, so now that I got my third row okay, I want to deal with my second row. So I notice that my row 2, I just need to deal with getting rid of this 1 there, and I can get it to 0. That can be my first step here. So I'm just going to recognize that if I take row 2 minus it from row 3, that's going to be my no row 2, because I'm going to eliminate my 1 by doing that in that third column. So when I do this, it's going to be first and the last row is not changing. So it's 1, negative 1, 1, 2. This is going to be 0, 0, 1, 1. So my row 2, I take my previous row, negative 2, minus that. Well, that's going to be negative 2 there. And then I'm going to have 1 minus 1, which is going to be 0. And then I'm going to have 2 minus 1, which is going to be 1. So there's my augmented matrix for that one. So the only thing I have left to do is multiply this one, my R2. If I multiply that by negative 1/2, that whole row, I'm going to go ahead and see that I get one step closer to my reduced row echelon. And this is just going to be equal to my R2. I'm not going to add it or subtract it to anything. So I'm at 1, -1, 1, 2. And I'm going to be 0, -2, 0. Oh, that's the one that's changing. So that's going to be 1, 0, -1/2, 0, 0, 1, 1. And I've reduced rows 2 and 3. Last step is reducing row 1. Well, this is analogous to having solutions for your x and z, so it's kind of like substitution. So what you're going to want to do is just use rows 2 and 3 to eliminate this -1 and 1 in row 1. So I'm going to take my row 1, and I want to add it to row 2. That's going to eliminate this -1 plus 1. I'll get 0 there. Now how am I going to eliminate that one? Well, I want to go ahead and subtract R3 from that. When all those other zeros are out, it'll make things a lot easier. And this is going to be my new R1. So let's go ahead and do that. So row 1 plus row 2 minus row 3, I get 1 there. Row 1 plus row 2 plus 0 minus 0, I get 0 there. 1 plus 0 minus 1, I'm going to get 0 here. And the last one, I'm going to get 2 plus -1/2, which is going to give me 3/2, minus 1 is just going to give me 1/2. Then these other rows stay the same. And this is my reduced row echelon form. What's nice about this, I can see that x is equal to 1/2, y is equal to -1/2, and z is equal to 1. Might be nice just to verify. Let's just try it on the first one. So I substitute in x into this equation, x, y, and z. I'm going to get 1/2 minus -1/2 plus 1 is equal to 1 plus 1, which is equal to 2. Verified that solution. So not all forms are you going to be able to get exactly into reduced row echelon form. That looks with ones all the way down the diagonals. If you do get one all the way down the diagonals and zeros in the other things, then you know that you're going to have a consistent solution. Okay? And that consistent solution is going to be independent. You will have an answer you'll have one exact answer. For instance, you can see that this is when x is equal to -4 and y is equal to 0. The other thing is if you do elimination and you eliminate a whole row and they're all zeros, what this means is, yes, you're still consistent, because right here, you're pretty much saying that 0 is equal to 0. It's a true statement. So you still have solutions, but it's dependent. Okay? If you end up getting a false statement, so something like this, where you're getting that 0 would be equal to -6. That's false. In this case, this means that it's going to be inconsistent. Okay, there aren't any solutions. Well, when you reduce it, you get a fallacy, which 0 is equal to -6. Well, it's going to be inconsistent, no solutions. Okay, Well, good news. We will be required to be able to do this by hand, but our calculators can do this as well, because frankly, matrices are what computers and calculators use. So let's go ahead and see how we do this in a calculator. All right, to do this calculator, first we got to make sure we can put this into an augmented matrix. So this augmented matrix is going to be 25, 61, negative 12, 25. I'm going to get 18, negative 12, 7, and 10, 3, 4, negative 1, negative 4. There's my augmented matrix. So in my calculator, I'm going to head and let's turn it on. First thing what we want to do is we want to go to our matrix. So if you see that inverse button, and it's in the blue, you do second, X1, and you can see that you get the matrix. What we want to do is we want to edit. So we're going to scroll over and go to the edit feature and hit enter. And we're going to have to change our matrix. Well, this one is a 3 by 4, so I type in 3, I type in 4. Okay, then I just type in the values. So I had 25, it shifts right. So I get 61, negative 12, 25. Second row, 18, negative 12, 7, and 10. Third row, 3, 4, negative 1, and negative 4. Okay, so now that I have that matrix in my calculator, I'm going to quit out of this, and I want to calculate something with my matrix. So again, I go to second matrix, and now I want to do some math upon it and do some calculations. And we're going to have to scroll down a little bit to see our RREF. There's REF, and RREF is there, capital B. I'm going to hit enter. And it's going to say, what do you want to do that of? Well, I want to do it of that matrix I just put in, matrix A. So I do second matrix, and I want to select matrix 1, there A. So I hit enter. And then I just close my parentheses and hit enter. And my calculator is going to do the work for us. So we can see that it's gotten in reduced row echelon form, and I want to go to the nearest hundredth. So I'm going to get 1, 0, 0, negative 2.05, 0, 1, 0, 3.88, and 0, 0, 1, and 13.36. So just like before, I can show that this solution here is my x, this is my y, and this is my z solution for that system of equation. A lot faster than trying to go through it by hand, but you will be accountable for knowing how to do a simpler equation by hand. Go ahead and highlight notes and bring questions to class tomorrow.